Hi, pre-AP students. So we are going to go over dividing fractions. Part of it is going to be a little review from 6th grade, but this is something that we should have spent more time on in 4th quarter, but we chose not to because the distance learning, this would be too complicated of a topic to do via the computer instead of face-to-face. So I do know that the 7th grade teachers know that they will need to review this, but I just wanted to go ahead and give the pre-AP students kind of a heads up so that you understand. The reason we're doing fractions this week is because I asked some of my former students that are now 7th graders in pre-AP what were some areas that they felt they needed more practice on, and they said fraction operations. So if you really struggle with fractions, that might be something you work on this summer through Khan Academy or different programs. I'd be more than happy to post a video or an activity once a week if you guys want to. Let me know. So let's get started. Okay, so let's take a look back at what we've already learned this year. So we've learned how to divide a whole by a fraction. So we have to think if I have 6 wholes, I'm not going to draw all 6 out. I'm just going to draw one. And I divide that into thirds. Because remember, division means how many of these will fit into here. So if I'm looking at this, each one of these represents a third. That's a third, that's a third, and that's a third. So in one whole, there are 3 thirds, which is why 3 thirds is a whole. Well, but if I have 6, that would mean if I have 3 and 1, to get to 6, I'd multiply by 6. So this would be 18. And what some of my students discovered was, oh, it's 6 times 3, and that gave them the 18. Well, then we transitioned to looking at, well, what if it was 2 thirds and it wasn't just 1 third? And I am going to draw these out so we can have a good understanding. Okay, so this time we have 2 thirds. So we could say, oh, that's a group, this is a group, that's a group. So there's 3, 4, 5, 6. But then we had leftovers. But we remember they're like snap cubes. You could take them and move them. So there's 7 and 8, and then these two could go together, and that would be 9. So there are 9 in there, which would make sense if you think about 6 and 1/3 was 18. 2 thirds would just group them into 2s, which is 9. What some of my students noticed was, well, 6 times 3 was 18 because it broke into 18 pieces. The thirds broke it into 18 pieces, and then we had to group them by 2, so then they did the 18 divided by 2, which gave them the 9. Another way you can look at this, which let me erase this real quick, sorry, is by thinking, okay, if I change my 6 wholes into a third, that would be times 3. This would become times, so there's 18 thirds, and 18 thirds, well, I don't want to put it with that equal sign because those wouldn't be equal. 18 thirds divided by 2 thirds. 8 divided by 2 is 9. 3 divided by 3 is 1, so that would just be 9. Okay, that's another way you can think of it. Okay, a fraction divided by a fraction. I'm not sure if the other teachers got into this. I touched on it very shortly, so we didn't spend a lot of time on it, but let's do an example. So let's say I had 3/4 divided by a half. So I brought this so I could draw 3/4. So here would be my 4, and I have 3/4. And I'm going to switch colors. And here's the thing, for the second fraction, I need it to be the same size as the first to see how many would fit in there. So, and then a half would be here. So I can see that this is here, so I know it fits in there one whole time. And then I would have this 1 left over, and it's out of the 2 that I need because I need 2 pieces to make the home. So what does this look like mathematically where you're not having to draw it? We could do it as 3/4 divided by, and change that half like we did in our drawing here to be 2/4 because they're equivalent, a half and 2/4. I'm not changing the problem, just changing the way this value looks. So we can see 3 divided by 2 would give me the 1 1/2 because 4 divided by 4 just becomes 1 and cancels out. Okay, let's do another example. Okay, let's look at another example. Let's do 5/9 divided by 1/3. So first I'm going to draw the model here. 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay. So here's 9, and I have 5 of these. Okay, and then I'm dividing that by 1/3. Well, I have to think, so I'm going to switch colors for the third because it just helps me visualize. So 1/3 would be this. So if I did another 3, I have another 1/3. If I do another 3, I have another 1. So then you can see, oh, okay, so this is 1/3 of the 9th. 3, because what we're creating is we're saying, I need to make this 1/3 into a 9th so I can compare it to the 5/9. So we use that ratio, equivalent fractions, so that would be 3/9. So then we can clearly see, oh, there's 1. This will fit in here 1 time. But then I have these 2 left over out of the 3 that I need. So what does this look like mathematically? It would just be 5/9 divided by, we would equivalent fraction 3/9. 3 will go into 5 1 whole time. You would have 2 left over. The 9s would cancel. 9 divided by 9 is just 1. 1 2/3. Does not. Oh. Okay, let's take a look at a problem where the first fraction, the one that's being divided, is less than the one it's being divided by. So first thing, just like we've done on all the other ones, we need to find that equivalent fraction for half because we need them to have the same denominator. So we know that 2 times 2 is 4, so 1 times 2 would be 2. So now we have 2/4 divided by 3/4. Okay, and the 4 divided by 4 just becomes 1. Well, then we have 2 divided by 3. Well, we know 3 does not go into 2, so that just leaves you the fraction of 2/3, which is also 2 divided by 3 because we can't divide 2 by 3. How does this look visually? Some of you might need to actual visualize this to have a better understanding. So if I'm looking at this, I'm going to switch my colors. So if I have 2/4 here and 2/3 here, and I am trying to fit the blue into this, I can see that I have 2 of the ones I need, but I need 3 to make a whole because this is representing a whole group. So I don't have the whole group. I have 2 of the 3 that I need. So that's where that's coming from. Okay, let's do one more example of this type of problem. So we have 3/8 divided by 5/6. So this would be one where I wouldn't model it because what you have to think is what numbers does 6 and 8 have in common? Because right now they do not have a common denominator. So one way you can do this is listing them. Some of you might know it off the top of your head. So those are my 6s, and then I would start working on my 8s. Oh, there's the common denominator. That's your least common denominator. So we would change these both to be out of 24. And remember, the golden rule in math is if you change one, you have to change the other. Well, how do I get from 8 to 24? That would be times 3. So 3 times 3 is 9. And then same thing here. How did I get from 6 to 24? I did 6 times 4, so 5 times 4. So we can clearly see that 9/24 is less than the 20/24, so I'm not going to get a whole. So I'm going to have the 24 divided by 24 cancels out, so now I just have 9 divided by 20, which we would just write as 9/20 because 20 cannot go into 9. And that's it. That's dividing a fraction by a fraction. If you can find those common denominators, it'd be super quick. Okay, so let's do some mixed number divided by a fraction. So really, there's only one extra step on this one, is changing those mixed numbers into impropers. And then you would divide it the exact same way I showed the other ones. So a way that my students in Texas remembered it is they called it the Texas. So you would do 5 times 2, you have to follow order of operations, is 10, plus the one on top is 11. So to change that into an improper would be 11 halves. So we would change this now to be 11 halves divided by 1/4. If you're still kind of like, where did this come from? Think of it as a whole would be 2 out of 2, and you had 5 of those, which is where the 10 comes from, and then plus the half that you already had. So that's where the 11 halves is coming from. My students in Texas just enjoyed the TX to remember what to do. Okay, so then we still have to follow the same rule. We have to have that common denominator. They do not right now, so 11 halves to be out of a 4th would be 2 times 2 is 4. So we would have to do 11 times 2 here, which is 22. So then we'd rewrite the problem one more time. And now we can actually solve it. 22/4 divided by 1/4 would actually be just 22. 4 divided by 4 cancels out because it becomes just 1. 22 divided by 1. And that's it. That's dividing a mixed number by a fraction. Let's do one more and we are done. Okay, so let's do 8 2/3 divided by a half. So the first thing we need to do is change this mixed number into an improper. So we have to think, if I had 8 wholes of 3/3, that would be 24/3. Plus the 2 up there is 26/3. But remember, you can use the Texas if you need to remember. Divided by half. Okay, the denominators are not the same. So if 3 can't go to 2 and 2 can't go to 3, but they have 6 in common. So we're going to change them both to be out of 6. So 2 times 3 gives me 6. So 1 times 3 would have to be done here. 3 times 2 gives me 6. So 26 times 2 is actually 52. So now we're doing 52 6 divided by 3 6. 6 divided by 6 makes 1. And we know a denominator of 1 just means a whole number. So then we have 52 divided by 3. So if we go over to our long division, 3 goes into 5 one time. We have a remainder of 2. 3 goes into 22 7 times with a remainder of 1. We're not going to keep dividing to get a decimal. You could, but we're going to leave it as a fraction since this is a fraction problem. So we have 17 and we have a remainder of 1 out of, we needed 3. So it'd be 1/3. Okay, so we are done. If you have any questions, please reach out. I'm here to help. Have a great day.